First of all, my apologies about the previous PowerPoint. That was, of course, Chapter 11B, not 10B. And sorry I ran out of time at the end to describe the lightning detection systems and lightning detection around the world, but you can pretty much read about that. Now, we are graduating from the chapter on thunderstorms, which is Chapter 11, to the chapter on tornadoes, Chapter 12. These extreme weather phenomena are things that people are really, really interested in, especially here in California because we don't have too many tornadoes. This chapter will cover the following topics: what the definition of a tornado is, the life cycle of a tornado occurrence and distribution, mainly in North America. We'll talk about winds associated with tornadoes, tornado outbreaks where you have several tornadoes in one occurrence, tornado formation, how we detect tornadic winds with Doppler radar, and talk a little bit about waterspouts, which are essentially are tornadoes over water. What is a tornado? Well, basically, it's a rapidly rotating column of air that blows around a small area of intense low pressure, and that circulation reaches the ground. Now, the condensation funnel itself may not reach all the way to the ground, especially if there's very dry air on the surface, but if that condensation funnel dips low enough to get close enough to the ground to cause debris to be taken up from the surface, then it can still be called a tornado. If a tornado circulation does not reach the ground, it's called a funnel cloud, and we have those here in the spring from time to time here in Central California. Most tornadoes have wind speeds of less than 135 miles an hour, but they can occasionally exceed 250 miles an hour in the strongest tornadoes. It's a nice picture from your book of a tornado in south central Kansas. Now, the white spots flying around in the picture are hailstones. Oh yeah, they can get big sometimes. Most tornadoes are between 300 feet and 2,000 feet wide, but they have been observed to be as narrow as 20 feet, if you can imagine that. But the most destructive and dangerous of tornadoes have been as wide as 1.5 miles. Okay, now keep in mind that the plot of land that Fresno State is on is about 1 square mile. So if you can imagine a tornado 1.5 miles wide, that gives you some perspective. Now, tornadoes tend to move from southwest to northeast, especially if they're steered by cold fronts. But we can use the old joke of what does a bull do in a China store? And the punchline to that joke is anything it wants, meaning that they can move, these tornadoes. Tornadoes can move in any direction they want to, but they do tend to move from southwest to northeast in North America, especially if they're governed by or moved along by cold fronts. They often have a forward speed of between, say, 20 and 50 miles an hour, but they can move faster than 80 miles an hour at times. Most of them only last a few minutes. The average length of the path of a tornado is 4 miles, but of course there are many, many exceptions to that. There are basically 3 stages of tornado development that we'll discuss in Chapter 12A PowerPoint here. The dust whirl stage, which marks the circulation on the ground, not much damage. The mature stage is when the damage is usually greatest and the funnel is widest. And then the decay stage, which means it kind of ropes out or looks like it's shaped by a rope whipping around in the sky. Weaker tornadoes can actually skip the mature stage and go right from the dust whirl stage to the decay stage. The deadliest tornadoes, -1. Why do I say that? Well, because just 2 years ago, on May the 22nd, 2011, there was one single tornado that killed 160 people. That tornado was not found in this list. Why? Because the ink was dry on your textbook just a few months before this particular tornado I'm referring to occurred. In the United States, we average about 1,000 tornadoes a year, more than anywhere else in the world. Some years it can be more than others, some less than others. It just depends on the weather pattern across the United States. Now, according to your textbook, a record of 1,722 tornadoes occurred in calendar year 2004. The Storm Prediction Center website says there were 1,820 tornadoes in 2004. The Storm Prediction Center website also says there were 1,894 tornadoes in 2011. So this gives you some idea of the extremes. It seems in the last decade we've had certain years where we've had a lot more tornadoes than is typical. Tornadoes have occurred in all 50 states, but they most frequently occur in a part of the continental United States that we refer to as Tornado Alley in the central U.S., where climatology and topography conspire for a high frequency frequency of tornado occurrence. There is also in the deep southern United States an area called Dixie Alley where tornadoes can occur, sometimes in the late fall and early spring, another area which is targeted, so to speak. Here's a graphic from your textbook, figure 12.4. The top figure shows the average annual numbers of tornadoes between 1953 and 2004, and the bottom figure on the map at each location shows the average number of tornadoes per 10,000 square miles. And once again, with respect to tornado development, you can see a bullseye right over central Oklahoma. No surprise there. Tornado meteorology is actually very similar to supercell thunderstorm meteorology when you have very strong vertical wind shear existing, meaning that there is a strong veering of wind direction with altitude from the surface and a strong increase in wind speeds from the surface with warm, moist air on the surface and cold, dry air aloft, and a polar jet stream paying a visit aloft right above an area where warm, humid air, is converging on the surface over the central and southern plains from the Gulf of Mexico. This is common in spring and early summer. This is a condition conducive to at least supercell thunderstorm formation, which is often a precursor to tornado formation. The spring and early summer and the central and southern Great Plains of the U.S. is the main target area where this occurs. May is the month for tornadoes, hands down. That's when you still have continental polar air masses coming down from Canada and increasingly maritime tropical air coming up from the Gulf of Mexico, and where they collide in the Central Plains, watch out. And May, followed by June. Those are the two peak months for tornado occurrence in the United States. With respect to the time of day when they are most frequent, well, mid to late afternoon, there you go, right around commute time, 5 p.m. This figure, 12.7, shows the average number of tornadoes in the U.S. for every hour of the day. This is a national average and doesn't reflect differences in various states, but it gives you a pretty good idea that mid to late afternoon is the main time of day for tornado occurrence. Now, as far as tornado winds are concerned, there have been a number of studies done in the last 4 decades, and they reveal that even the most powerful twisters seldom have winds exceeding 250 miles an hour. Wind speeds are either estimated by examining storm damage after the fact, or by indirect measurements using nearby National Weather Service Doppler radar, or researchers from universities will drive to where they can get as close to tornadoes as they can and stay out of harm's way, and measure with what they call a Doppler on wheels. And I'll show you more about that later on in this chapter. A tornado moving from southwest to northeast will have its strongest winds on the southeast side of it, as seen in figure 12.9. You see the strongest winds with this tornado are 150 miles an hour in the southeastern quadrant of the tornado. Now, many violent tornadoes can have smaller whirls inside of them, and such tornadoes are called multi-vortex tornadoes, and the smaller whirls within them are called suction vortices. Now, the damage that's caused by a multi-vortex tornado may not be evenly distributed due to obviously the variability of wind speeds within them. It is now known that opening windows during a tornado increases the pressure on the opposite side, the opposite wall, which increases the odds that the buildings will collapse. You hear these suburban or rural legends, or old wives' tales, if you will. Oh, we have to get out of the house, but before we do, let's open all the windows. It'll decrease the amount of pressure in the house, and maybe it won't cause the house to collapse. Well, that's just not true scientifically. Opening windows during a tornado increases the pressure on the opposite wall, increases the odds a building will collapse. You don't want to take the time to do that anyway. If there's a tornado coming toward you, you want to get the heck out of the way, that's for sure. Figure 12.10 represents a powerful multi-vortex tornado with suction vortices. Figure 12.11 shows a suction vortex within a large tornado and how it can cause substantial wind, how the wind speed can increase substantially, and it might cause spiral markings on the ground. Two good illustrations from the beginning of chapter 12 in your textbook. All right, a few do's and don'ts. these are, very common sense things, and we do not have tornadoes often here in Central California, but, to be on the safe side, here's the deal. You want to seek shelter immediately. If you're in a house that's got a basement, that's the preferable place to be. If you don't have a basement, you can go to a small room like a bathroom or a closet or a hallway or on the lowest floor of the building and in the middle of the house. If you're in a mobile home and a tornado is coming toward you, get out of that mobile home. If there is no substantial building nearby to get into, lie flat on the ground in a depression or a ravine. Don't try to outrun a tornado in a vehicle. Stop and let the tornado go by, or turn around and drive in the opposite direction that the tornado is going toward. Do not seek shelter in a freeway underpass. It's a very dangerous thing to do. The Storm Prediction Center is located in Norman, Oklahoma, and its primary task is to issue severe thunderstorm watches or tornado watches. Now, those sorts of watches are rare in January, but the area in yellow through Georgia and North Carolina and South Carolina indicates a tornado watch on January 30th, 2013, stretching from southeast Alabama all the way up to western North Carolina. Once the local Weather Service office actually sees severe weather or gets severe weather reports, they are the ones that will issue a short-term warning, a severe thunderstorm warning or a tornado warning. Here is the map from January 30th, 2013 from the National Weather Service office in Greenville, Spartanburg, North Carolina, showing the yellow area where the tornado watch is in effect and the orange area where severe thunderstorm watches are in effect, and the red areas where tornado warnings were in effect at that time. Now, despite the large increase in population in the tornado belt in the last 30 years, tornado-related deaths have actually shown a decrease. In recent years, however, there has been an increase in the number of tornado fatalities occurring in mobile homes because, well, they're cheaper to live in, but of course in those areas of the U.S. where tornadoes are more frequent, that becomes a problem. And there aren't necessarily more tornadoes now than there used to be. There are just more people to see them as population increases, and there's better science to detect them. I mean, look, even with a dumb phone, you can record a video of a tornado. You don't need a smartphone to do that. This chart shows you the average annual number of tornadoes and tornado deaths by decade in the United States to give you an idea of the distribution of this. Here is a picture of a tornado hitting Adairsville, Georgia on Wednesday, January 30th, 2013. Again, tornadoes are rare in the wintertime in the United States, but every once in a while in winter you can get a spring weather pattern that can produce tornadoes. So I thought I would show you that. The benchmark researcher in tornadoes was Dr. Theodore Fujita, who was with the University of Chicago, and he proposed a scale for classifying tornadoes based on their rotational wind speeds. This is back in 1971. The winds were estimated by the damage the storm left behind, and they were based on the damage to a single-family wood frame house. Well, this is rather subjective. So in February of 2007, the National Weather Service adopted and started to use the Enhanced Fujita Scale, which attempts to provide a wider range of criteria in estimating a tornado's winds by using a set of 28 damage indicators, not just damage indicators for a single-family residence. This is a table showing the original Fujita scale for damaging winds. You can examine that as you read the chapter. This is the modified or enhanced Fujita scale for damaging winds for tornadoes, which has been in use now in the United States since February of 2007. Now, what I'm about to show you is what tornadoes of differing strengths on the enhanced Fujita scale, or the EF scale, can do to a single-family two-story residence. So here is what the damage may look like after an EF0 passes by. Here's the damage if an EF1 passes by with stronger winds. Progressively stronger, the damage potentially from an EF2, an EF3, an EF4, and by the time you get to EF5, or wind speeds are in excess of 200 miles an hour, then you have basically catastrophic damage to a single-family residence. There's no question about this. This is an aerial view of Greensburg, Kansas, a small town in Kansas, prior to a tornado hitting there in May of 2007. This is that same area, an aerial view, after an EF5 tornado hit. on May 4th, 2007, essentially destroying the town. So obviously, every once in a while, you can get one tornado that hits one town, and you have an anomaly where you have more deaths than average in a particular year. Quite poignant, this photograph is indeed. So that ends Chapter 12a. We will continue to explore tornadoes in the PowerPoint for Chapter 12b.